Let's give you guys a Calculus 2 solid of revolution exercise. So here you've got y equals x squared. So this is your y equals x squared graph. We're going to revolve this 360 along the y-axis. So it will give you this solid. The question is, find a value of a for which this solid is the same as you revolving it 360 along the x-axis. Don't forget you've got the negative side here. So this will then give you this solid here if you revolve it around the x-axis. So it will give you this solid here. Find a value of a for which this solid, let's call it V2, is the same as this solid here, which we are going to call V1. So find a value of a for which V1 equals V2. So press pause and have a go. Okay, let's do V1 first. So V1, you're moving along in the y direction, so it's going to be something of the form the integral from well, it's going to be something in the y direction, and you're moving along like this. Let's say you're currently at this level, this height y. For given y, what is the radius here? Because we need to pi r square it later to get a disk. So so for given y, how do you work out this this radius, so to speak? How do you work out this length? Well, put y into here, into here, and make x the subject, because you want to know the value of x for given y. Well, square root both sides, so y square root of y equals x. Well, for given y, if you square root it, it will then give you this length. So so this length is actually square root of y. Once you've got this radius, then quickly pi r square it. That will give you the area of the disk. So it would be once you've got the radius, which was root y, once you've got the radius, quickly pi r square it. That will give you the area of the disk, and you're really summing up all the disks from 0 to this height here. Well, this height here is given by a squared, so from 0 to a squared. So V1 is given by this. V1 is given by this, and now let's work out V2. V2 is this solid here. V2 is this solid here. So rather than integrating so V2 is equal to, rather than integrating from negative a to positive a, we are just going to integrate it from 0 to a and then multiply by 2 because it's symmetrical. So don't forget we're moving along in the x direction. So we're moving along in the x direction. Hang on, let me clean this up. So we're moving along in the x direction, so it's going to be something dx because we're moving in the x direction, so we're moving along like this in the x direction. Let's say x is currently here. For any given x, what is this radius, so to speak? Because we need to pi r square it to give us the area of the disk. So so for given value of x, if you square it, it will give you the radius, so to speak. So this length here is x squared. So once you've got the radius, once you've got the radius, which is x squared, once you've got the radius, quickly pi r square it. So quickly pi r square it. That will then give you that will then give you the area of the disk, and then you're summing up all the disks from 0 to a. So that will give you half of it, and then when you multiply it by 2, it will give you the other half. Okay, so V2 is given by the integral. V2 is given by the integral. V2 is given by 2 lots of the integral from 0 to a, and it was pi x squared squared dx. So now you want to find a value of a. You want to find a value of a for which this volume is the same as this volume. So set the two to be the same. So set this to be the same as this. So we're looking for a value of a. So we're looking for a value of a for which this volume is the same as this volume. So now don't forget over here you're integrating it with respect to y. The pi has nothing to do with y, it's a constant, so drag it out. And then here the pi has nothing to do with x, so drag it out. And now when you square a square root, this thing will just simply be y. When you square an x squared, it will give you to the power of 4. And then now divide both sides by pi. So that will then give us this thing here. Now integrate both sides. On the left hand side you're integrating it with respect to y. So when you integrate this it will be y squared over 2. Here you're integrating with respect to x. So so that would be to the power of 5 over 5. Now put this into the y. That will give you a squared squared, which is to the power of 4. And then take away, and when you put 0 into here it disappears. So this whole block here becomes this, and the same goes for over here. This whole thing here will then become this. And now hang on, let me think. So now this 2 here gets multiplied to the top, giving you this. From here, times both sides by 5 and times both sides by 2. That will then give you this thing here. And then divide both sides by a to the power of 4. That will then give you this. So a equals 5 over 4. So what that means is, at this precise value here, 5 over 4, this volume here is the same as this volume here. Okay, so your final answer is 5 over 4.